Number 14. Mr. Thomas is sketching a scale model of a park. The length of the park is 500 yards and the width of the park is 200 yards. So here's the actual park. Um, 500 yards and 200 yards. He drew the length as 25 inches and the width as blank inches. So we are going to take this big park and we are going to scale it down to a drawing. Okay. So that's a mama and a baby shape. I'm going to remove the units because this is the actual units. This is the drawing units. And the length on the drawing is 25 inches. So whatever we get here will also be in inches. Those units have to match up. So I'm going to compare the length to the width in the ratio. So 500 to 200 is proportionate to 25 to the unknown. So we're going to say 200 times 25. That is 50 and 2 zeros. And then 5,000 divided by 500 is going to be 10. So the missing dimension is 10 inches. And that is not multiple choice, so we'll have to just fill in the blank there for number 14. Number 15. Oh boy, here's another marble problem. A bag has 5 yellow marbles, again, if you want to fast forward through this, I totally understand that. Yellow, you can also just relax for a minute while I draw these in, if you would like to do that too. 5 yellow and 7 green. So let me make this fella green. That shade of green makes my head hurt. One, 2, 3, 4, 5, 6, 7. All right, so there are the marbles in the bag. We have 5 yellow and 7 green. All right. What is the probability of drawing a green marble twice? And I need to be sure I read all of it, because I don't know if it's independent or dependent. Do they replace the marble or no? A bag has marbles. After a marble is drawn, it is set aside. So this is dependent probability. So the first marble I draw is out of 12 marbles, there are 7 green ones. So I'm going to pull a green one out of there. And I'm going to set it over here to the side. Now in the bag there are only 11 marbles and 6 of them are green. So I'll multiply 7 times 6 and then 12 times 11. And I'm sure this will simplify. I know at least by 2, but I suspect more than that. Just put it in your calculator as a fraction. And it does by 6. So I get 7 over 22, which is 3181 repeating. The 81 repeats. So 31.81%. But the answers are in terms of fractions. I'm going to go with B on that one for number 15. Number 16. A gym charges $40 a month for membership in 2013. In 2014, the price increases to $45 a month. What was the percent change in the price? Well, the difference $45 minus $40 is $5, and that was an increase. So to find the percentage, you can set up a proportion of 100. The difference always is the part, and you always use the original down here. So you have 5 times 100, that's 500, divide by 40 is 12.5%. And again, that was an increase, so that's a positive 12.5. So I like answer C for number 16. Number 17. A club is electing a president, vice president, and treasurer. There are 7 people running for positions, and no one can hold more than one position. How many ways can the positions be filled? Well, this is a permutation because order matters. N is going to be 7. K is 3. That's the positions, president, vice president, and treasurer. And if you want to use the formula, it looks like this. N factorial, N minus K factorial is 7 factorial over 4 factorial. 7 shift 3 is 50/40. 4 shift 3 is 24. And 50/40 divided by 24 is 210. You can also put in the calculator steps. If you have forgotten those, I'll draw them for you. Remember, the permutation combination formulas are very similar, but they are different. Combinations remove redundancies. Permutations do not remove redundancies. So the steps are going to be all clear. 7, shift 1, 3 equals. 7 shift 1, 3 equals 210. So I like answer B as in boy for number 17. Number 18. This tree diagram shows all possible outcomes of rolling a blank. Let me read that again. This tree diagram shows all possible outcomes of rolling a. It's not 2 dice. It's 1 die. Two rolls. I think. Let me study this here. First roll. You have 2. Yes, that's right. You have either even or odd. You pick up the same die again and roll it a second time. And then you could have even or odd. So you could have all even. You could have even odd. You could have odd even or odd odd. So it's 1 die, 2 rolls. 2 rolls of the same die. We will check that here in just a second. I have to go to the back of the book to do that. So